Hi, I'm Dr. Papia Bhattacharjee. In this problem, we have two functions. F is e to the 2x exponential function and g is a natural log function, ln of square root of x. What we have to do is show that these two functions are inverse functions. So they're inverse to each other. All right, so let's recall, how do we show that two functions are inverse to each other? So how about properties of inverse functions? Recall further that usually, given a function f, we call its inverse f to the power -1 or f inverse. And the properties are, 1, whenever we have f of f inverse of x, so f and f inverse together cancel each other and you get x. Second property is the same thing except f and f inverse, they are reversed. So f inverse of f of x is also x. So basically the idea is whenever f and f inverse, they are next to each other, they cancel. So using these two properties, we can show that f and g will be inverse to each other. So basically what we want to show is that one of these, so let's say g is f inverse. That's what we want to show. Okay, so let's start with the first property. How about f of g of x? Let's see what we get when we compose these two functions. Now, how do we evaluate the function f at g of x? Go back to the expression for the function. F of x is e to the 2x. So imagine wherever you have this variable x, it's like there is an empty box in there. Okay, so you're putting this x inside a box. So the right hand side also, your x is inside a box. So now in that box, instead of x, you're plugging in gx. So that's how you will know what expression you should get on the right hand side. So if you plug in gx inside that box, in the right hand side you will get e to the power 2 times, in the box you have gx, so you will have g of x here. Okay, so that's how we evaluate a function at some point or some expression. All right, now let's compute this right hand side. Okay, so e to the power 2 times, now what is g of x? Now go down to the next function. G of x is this expression, natural log of square root of x. All right, now what do we do? How can we simplify this expression? Notice that since we have a natural log function and there's a constant in the front, we have a property of natural log that we can apply. Let me remind you of a property of natural log. And it says that if you have ln of some a to the power r, then that is equal to, you can bring that r down from the exponent, it is r times ln of a. Now note here, this is like, this 2 is like r. So this is like r. And you have ln of, this is a. So applying this property, so you have the right hand side, you can do the left hand side now. This will be ln of this a to the power r. So square root of x square. Right? The r goes in the exponent. And square root of x square is nothing but x. And notice e and ln, we know they're inverse of each other, so they cancel. and you ultimately get x. So the first property is satisfied by f and g. F of g of x is equal to x. Let's move on and try to see if the second property of inverse function is satisfied or not. So in this case, we are going to show g of f of x is x. All right. So let's do it the same way. What is g of f of x? So you're evaluating g at f of x. Again, go back to the g function and consider wherever there is x, there is an empty box. And so on the right hand side, wherever you have x, you have an empty box. So now in that empty box, you're plugging in fx. And so on the right hand side, you'll be plugging in f of x inside the square root, because that's where the box is. All right, now let's simplify. Write down your f of x. So this is natural log square root of e to the 2x. Okay. Let me write one more step here. This is also using the property of exponent. Remind you of this fact. See, e to the 2x can be rewritten as e to the x square. Because using property of exponent, the x and the 2 will get multiplied and you get 2x. The reason I wrote it this way, because now see you have a square root and inside you have a square. So the square root will go away. So this is nothing but natural log of just e to the x, because the square and the square root cancels. And again, ln and e, they're inverse functions. We know that. So they cancel and you end up getting x again. So both properties of inverse functions are satisfied by f and g. And hence we can conclude that g is the inverse of f. Or you can, otherwise you can say f and g are inverse to each other. So to finish this problem, let's use a graphing utility to show that f and g are inverse to each other. So pick a graphing utility that you have and let's plot these functions. So first, plot y1 equal to f. So let's call that one y1. So write down y1 is equal to e to the power 2x, and then g is your y2. So y2 is natural log of square root of x. And then keep the window, from negative 10 to 10 for x and negative 10 to 10 for y. So keep it square so that you can see that those two functions are inverse to each other or not. And then let's graph it. So you notice that the function on top of x-axis, above x-axis, that's your exponential function. And the function to the right side of y-axis, that's your natural log function. And they look like they're inverse to each other. Now, recall, how do we know graphically that the two functions are inverse to each other? If they are mirror images of each other, where the mirror is the line y equals x. So to see it better, why don't we also graph the line? So let's go back and say y3 is x, and then graph it again. And you can see very clearly that the two functions are like mirror images where the mirror is y equals x. And that verifies that f and g are inverse to each other. Thank you.